I noticed that those 8s would cancel, so it'd be
1 over x.
1 over x.
Yeah.
Okay, now it doesn't always work out like that. Like, let's say it's the natural log of like 3 plus x, or let me put a 2 there, 3 plus 2x. So this becomes 1 over 3 plus 2x times the derivative of the inside function, which is 2.
Is it always 1 over something? Or I thought it was
Yes.
derivative of the inside over the
Eh,
inside.
Yeah, I actually preferred it. My preference would have been 1 over
Oh,
the, but it's
I
the same
actually,
thing.
yeah, okay, yeah, I see that.
The same thing. Okay, so where this gets more complicated is like, let's say, and I'll have you jump in here. Let's say it's like the natural log of sine x. Could you try to take the derivative of that for us, please?
Yeah. It'd be cotangent or cosine x over sine x.
Right. So sometimes you get, some niceness with the simplification. Cosine x over sine x is cotangent x. Very good. All right. Now, the other type of function you'll see here is when you get y equals, I don't know, log base 2 of like 4x. Did you guys cover stuff like this?
Yeah, we just make them into natural logs, right? So like natural log of 4x over natural log of 2.
That is one way to do it. If that's the way you've presented it, I can do it that way. I can also show you an alternative way, which I mean it's really the same, but it's um it's 1 over the inside function times the derivative of the inside function, just like before, but you have to take the natural log of the base, which is exactly what you just said.
Yeah.
So if you don't like the way your teacher presented it, or you want to try it, it's the same result.
Can we just stick to making them like ln over ln?
Sure.
Okay.
So and just I'll just make one more point. This is not the way it's typically taught. Um, so just keep that in mind. But
Okay.
because now you have to see this as 1 over natural log of 2 is like a coefficient
Yeah, it's like a
of
he
it.
calls it a constant. Yeah.
It is. And it's
Yeah.
so it's still the same result. It's still absolutely the same. It's over 4x times the derivative. Um, but you can see here trying to make the case here, it's a lot more work.
Yeah.
The fours cancel, you get a 1 on top, so it's 1 over natural log of 2 times x. Or yeah, natural log of 2 times x.
Yeah.
Okay. Um, let me see what you've got here for so like a problem here, because there's also these property of logarithms that you need to know about. So I'll grab one from
Yeah, I
your
have them written
text.
down.
So this one, you can use the rules that we've been doing, but you can also use the fact that natural log of a over b becomes the natural log of a minus the natural log of b.
Yeah, that's what we've been doing.
And it does make sense to do that here.
Okay.
So could you take a derivative from this point?
I think so, yeah. Do I have to simplify it? Or can I just leave it as two separate, like,
It depends on your instructor. I think you can leave it separate.
okay. I'm pretty sure I could too. So, I
So
got
here,
5 over 5x plus 2
okay,
minus 7 over 7x minus 8.
okay, very good. So the other type of problem you will see is something like this, where you use the product rule.
Okay.
So natural log of a times b becomes the natural log of a plus the natural log of b. this becomes natural log of 4x minus 7 plus natural log of x plus 10. Could you, well, it's right. This is the derivative again.
Yeah.
So here, like, so that kind of is pretty straightforward. Here's a problem where I feel like this is the kind of problem I would want to give. I would want to give you something like x, let me do it differently. Um, 2x minus 5 to the third, 3x plus 1 to the power squared over the square root of x minus 2. This would be my quiz question for you on something like this because it relies on you being able to break this apart using the logarithmic rules. You don't want to do quotient rule on this. Um, is this something you saw, anything like this that you saw in class?
I have not, but it's on my homework, so it's definitely something you could give me.
Okay. I didn't see any like this.
Oh, I thought there was, but we could still
I
talk
mean,
over this.
wait, let me check here. Not really. I mean, this is more complicated, but this one you would write out as the natural log, 3 natural log 2x minus 5 plus 2 natural log 3x plus 1 minus 1 half natural log x minus 2. This is the final result of using all the rules there.
Okay, so I'm bringing the net bottom to the top and making it into an exponent, right?
You are. So the square root is is a 1/2 power, but when you bring it up, it's uh or or it's a fraction, you subtract it. It depends on how you look at it. Because last students remember that if it's on the bottom, you subtract. If it's on the top, you add.
Okay, that makes sense. And then I find the derivative of that, right?
Yes. So could you take the yeah, this could you take a derivative of this and let me know what you come up with, please?
Yeah. Okay, I got 6 over 2x minus 5 plus 6 over 3x plus 1 minus 1/2 over x minus 2.
All right. That's good for me. All right, so let's keep kind of going with this idea here. So here's a problem that is in your book. Um, this is not like the ones we just did, although maybe it looks like it is. It is not.
Because they're not combined in the ln, right?
That's right.
Okay.
So this is a product rule problem. Do you want to give this one a try? You know, F and G.
Yeah. Okay, I got 6 over 6x times ln of 4x plus ln of 6x times 4 over 4x.
Okay. I would want you to simplify these sixes and the fours,
Okay.
which mean you might end up write it like this.
Yeah, yeah.
And then you might even say, well, why don't I just put it there, you know, on top? I mean, there's a bunch of ways to present your answer, but that's pretty good. Okay. All right. Did you guys talk about Trying to find one here. I don't see it. Kind of see it in one of these problems. All right. So let's move to exponentials.
Okay.
You have to be comfortable with how you take a derivative of something like the following. 5x squared plus e to the 5x minus 5 to the 2x power. Okay. For some reason, these kind of all look the same, I guess. You know,
Yeah.
but we'll look at this one by one. Okay. So just as a reminder, power rule, if it's x to the n, if it's a variable to a number, okay, that's important. The derivative
Yeah.
is nx to the n minus one. Okay.
Yep.
Then you move to, they typically tell you, okay, if it's e, and I'm going to use u this time. If it's e to the u, the derivative is itself times u prime. Okay, so if it's e to the 5x, the derivative of this is itself times the derivative of 5x, which is 5. So you might write it as 5e to the 5x.
Yeah.
Okay. But what if it's, and this is pulling a problem from your book now, what if it's 8e to the x cubed? Well, the derivative is itself. It's always itself times the derivative of the inside function. The derivative of the inside function of x cubed is 3x squared.
So I'm multiplying 3. Okay.
And then you might simplify to 24x squared e x cubed, something like that.
Okay.
Right. So, but let's make this a little more difficult. Let's say it's 5e to the minus x plus 6e to the minus x to the fourth plus 1. Okay. So could you do the derivative of the first one for us, please?
Yes. So 5e to the negative x times negative 1.
Yeah. So it end up being negative 5e to the negative x.
And then we're going to do plus 6e negative x or to the power of negative x plus 1. Negative x plus 1. And then
What's the
times
derivative of
negative.
this?
Oh, wait. Negative 4x cubed.
All right. There's a plus in the middle there.
Yeah.
Okay. All right, so let's go. Let me just rewrite it here just in case you had to simplify it. End up being a minus 24x cubed e to the minus x to the fourth plus 1. All right. What if it was something like y equals e to the um, tangent of 2x?
So y prime equals e to the tangent 2x times 2 times secant squared 2x. Yeah.
Great. All right, so then the second type is like, what if you get a number to the power of x? Okay. Um, the derivative is itself times the natural log of the base.
Yep.
Okay. Now, more generally, though, it's like this. If it's b to the u, b is the number, u is the variable. The derivative is itself times the natural log of the base times u prime.
Yeah.
Okay. So let's look at a problem here. Let's say it was like y equals 7 to the x minus 7 to the 5x plus 1. Okay.
Okay.
So this would be itself, the derivative would be itself, natural log of the base minus itself, natural log of the base times the derivative of the exponent, which is 5.
Okay.
Okay, so where this gets a little bit awkward or weird is with coefficients. Let's say it's like 3 times 2 to the x minus 5 times 2 to the 9x squared. Could you attempt to take a derivative of this as best you can?
Yeah. Um, do the coefficients just cancel out to zero because they don't have a?
They come down with it.
Oh, okay. Then I
Yeah.
can do that. Okay. 3 times 2 to the power of x times the ln of 2 minus 5 times 2 to the power of 9x squared times 18x.
What about the natural log of 2? I don't know if I heard that or not.
Oh, I did not put natural log of 2.
Yeah.
Okay.
Okay, so I really like a problem like the following, just to see if you're comfortable with all this. Let's say it's like 5x squared minus x to the 2/5 plus 5 to the x over 2 minus 2 times 5 to the x.
Okay. Um, so y prime equals 10x minus 2/5 x minus 2/5 x to the negative 3/5 power plus 5 to the power of x divided by 2 times ln of 5 times what's the how do I take a derivative of a fraction?
Does that help? Maybe seeing that there.
Wait, what?
Well, the 1 over 2, does that help?
Oh, no.
Okay, you did it correctly here. You brought the exponent down. It's just 1/2. 1/2.
The derivative of x over 2 is 1/2?
Yeah, because it's really 1/2 times x. So it's just
Okay.
the coefficient.
So times 1/2 minus 2 times 5x times ln of 5.
Okay. All right, good. Any questions, thoughts on that?
Um, I actually feel pretty confident on that, I'm not gonna lie.
Okay. I'm just gonna look through your questions again here. There's a few other ones that I want us to do. There's a few different directions your instructor could go. Let's do a quotient rule here, just to make sure we do at least one. So let's go e to the 7x over the natural log of 3x.
Okay.
Go ahead and give that a try, please.
Okay, I got e to the power of 7x times 7 times ln of 3x minus e to the 7x times 1 over x, all divided by ln 3x squared.
So be really careful how you write the bottom squared, because you got to be careful that you don't think that it's like the 3x is squared. It's really natural log of 3x times natural log of 3x.
Yeah.
And just be careful. I mean, there are some simplifications, but all right, so that's really good. Okay, so sometimes you get to doing so many of these problems that you forget that you can rewrite. Okay, and that's kind of what we're going to focus on now. Like if I tell you that it's y equals e to the natural log of cosine of x, do you recall that you can simplify this first?
Um, no, I would have just
Okay,
done it.
okay. Well, it works. The derivative is, but it gets worse before it gets better. It's e to the natural log cosine of x times 1 over cosine of x times derivative of cosine is minus sine x.
Oh yeah,
Okay.
okay. Yeah.
And it looks weird. So the correct way to do it is to rewrite this as just the cosine of x. E and ln undo each other. They're inverses.
Oh
They
yeah.
undo each other.
Okay.
And you should simplify if you can.
So
So
it'd
like
just be
here's
cosine, right?
yeah,
Cosine x.
like sometimes the teacher can make it like really complicated, like I said, like, oh, it's like b squared over 9t, like that.
Mhm.
But this becomes t squared over 9t, which becomes t over 9, which is really 1 over 9 times t. The derivative is just 1 over 9.
Yeah.
So it's very easy to make it look really complicated. The other direction here that you'll see is what if you're given something like the natural log of e to the 4x? What does this reduce to?
Hmm. I have no idea.
Just the 4x
Oh, so they cancel out each other even if it's in front. Okay.
in both directions. Yeah. Yeah. So the derivative would be just 4. Now, what if I gave you a problem where it was the natural log of e to the 5x times natural log of e to the 2x? What does
It'd
this
be
become when you simplify?
5x times 2x.
Yes. And so you could use product rule, or you could continue multiplying.
Yeah.
And
So
now your
20.
derivative is 20x.
Okay. Makes sense.
Let's see what else. Let me make one or two up here, and then we'll talk about some more stuff.
Okay.
Let's go 6e to the natural log of 7x times the natural log of e to the uh let's go sorry, I'm losing my track here. Let's go
Okay.
just x, let's just go x plus 1. So could you attempt to simplify this first, and then
42x times x plus 1.
yeah, keep going.
Wait.
Like you
How
have
do I
to
keep?
take a derivative
Oh,
of
yeah.
all
Okay.
that.
Okay. It's really just 42.
Well, the first part's 42x, but this is times x plus 1. So you want to
Oh, it's
distribute.
just product rule, right?
I would not use product rule for that. Like I would distribute.
Oh, so 42x squared plus 42?
X, yeah. And then
84, so it's 84x
plus 42.
plus, wait, I thought the 42 cancels out.
Okay, we still have not taken a derivative, right? Like this is the simplified form. This is just power rule.
Oh, okay. Wait, I thought power rule gets me the derivative.
Yeah, I'm asking for the derivative of this.
Oh, okay, so 84. Oh, that makes sense. So 84x plus 42.
Yes. Okay, let me give you a couple more like this, at least one more. Okay, what does this simplify to when you're all done?
Oh, okay. Do you want me to go farther than negative 3x plus 3 times 1 over x plus 1?
Well, our goal is to take a derivative, right? It would say like, calculate, y prime. So all the reason I'm having you simplify all this is to get it to where you can then take a derivative. Now, you could take a derivative right now of this, but that would be product rule, maybe quotient rule.
Yeah.
Um, I would write it as a top and a bottom. And you can distribute it if you want. I think it's probably a good thing to do.
Okay, so
That negative that will cancel, should have canceled that with that. Sorry. So it'd be 3x
minus.
3x minus 3 over x plus 1. And then I want you to do a quotient rule derivative here.
Okay. I'm getting a 0 as a numerator. So
Uh,
I did 3x plus 1 or 3 times x plus 1 minus 3x minus 3 times 1 all over x plus 1 squared.
okay, so I think you gotta the x terms do cancel in the numerator, but there should be a constant left over. Um,
I got two threes.
okay, minus the top like that. So that's your top, some variation on that, right?
Yeah, that's exactly what I have.
Okay, so we got 3x plus 3 minus 3x plus 3. That actually does work out. You're right. Okay. That could have happened. I just made this up. I mean, I didn't
Okay.
really think that much about it.
Yeah.
Okay, another type of problem you'll see here, which we haven't done yet, is something like where it's like y equals the cosine of the natural log of x.
I have to do the derivative of the inside, for, like chain rule, right?
Yes, that derivative the outside, then the inside.
Okay. Negative sine 1x. Or negative sine 1 over x.
you got to keep the inside function first, then multiply by the derivative of the inside function.
Oh, okay. And then I can just put it all over x, right?
Yeah.
Okay.
So let's try another one here. Let's go like y equals tangent of e to the x. Try that.
Secant squared e to the x times e to the x, or e to the x squared, whatever. You can combine
Times e
them.
to the x. So no, you cannot
Oh, yeah.
combine these. They're like this is an inside function
Okay.
situation.
Okay.
All right. I still don't feel like you've got this fully down. Let's keep doing a few more of these. Let's go like natural log of sine of x squared. Let's try that.
Cosine x squared over sine x squared.
What about the derivative of the inside
Oh,
function?
you're right. So 2 cosine x squared? Or 2x, sorry.
Right. And then cosine over sine is cotangent. So you could write cotangent x squared times 2x. But
Okay.
more importantly, is you have to take the root of that inside function.
Okay.
All right, let's do another one here. How about y equals natural log of x plus e to the x squared.
Uh, so I bring the 2 down. So 2 times ln of x plus e to the x uh, times 1 over x plus e to the x.
Really good, really, really good. Okay, I think you're getting it. So I tend to not do as many log base b's and number to the power of x problems. I guess I don't know, do you have your book handy?
Yeah, I do have it right here.
Okay. Um, let me give you, let me just combine a couple of these. I think that would be the best way for me to do it. Make
Okay.
sure you've got this down. And then there's kind of like a few other directions we can go here with it. Let's go y equals 0.4 to the 2x minus natural log of x to the fifth plus x to the 1.03 power.
Okay. So 2 times 0.4 to the power of 2x times ln of 0.4 minus.
Whoop, there's a little bit more. What's the derivative of the inside function? Maybe you said it and I didn't hear it because I was
Yeah,
muted.
it's 2. Yeah.
Okay. All right.
And then minus 5x to the 4th power over x to the 5th power plus 1.03 x to the power of 0.3.
0.3.
Oh,
So this one you'd want to simplify. The first one you really can't. What would the middle one simplify to?
Um, 5 over x.
Yes. All right. So there's this classic problem they like to give you in calculus, which is to take the derivative of x to the x. Did you guys talk about this in class?
We did a problem like that today, but then it turns into like infinity or something, I think.
Okay.
Oh wait, no, we did that with limits. Sorry.
We'll get to yeah, we did
Yeah.
this is more related to logarithm differentiation. So this is this classic problem where until someone tells you what to do, you have no idea what to do. Um, you first start by taking the natural log of both sides of the equation. And then there's a property of logarithms that says to bring the exponent out in front. So again, no calculus, we're just multiplying or using rules. We're rewriting. This is all rewrite.
Yeah.
Okay. So this is an implicit derivative now. Um,
Mhm.
the derivative of natural log of y is 1 over y times dy dx. On the right side, it's product rule. Could you do product rule
Yeah.
derivative for us, please?
So ln of x plus x over x.
Does that reduce?
Um, don't they just cancel each other out to one?
Yes. So it's currently 1 over y times dy dx equals 1 plus the natural log of x. Is that okay?
Yes.
So to solve for dy dx, we multiply both sides by y. No, I don't want to do that right now. So on the left, you get dy dx. On the right, it's 1 plus natural log of x times y. If you recall, y was x to the x.
Yeah.
So this becomes dy dx equals 1 plus natural log of x times x to the x.
Okay. That makes sense.
Is that okay?
Yes.
All right, so I'd like you to try a really similar problem here. It's another classic problem here, taking the derivative of this. It's the exact same steps. It'll have kind of the same form as what we just did, but give that a try, please.
Okay. I got cosine x times ln of x plus sine of x over x, all multiplied by x to the power of sine x.
So something like this.
Yeah.
Okay, let's take a look here. So it becomes natural log of y equals sine x times natural log of x. Does that look like what you have?
Yes.
All right. And so the left always becomes 1 over y times dy dx. On the right, it's product rule. It's sine x times 1 over x plus
Mm-hmm.
cosine x times natural log of x, which is kind of what you have here. I don't know if you meant to say it this way.
Yeah, I have cosine ln of or cosine x times ln of x
Okay,
plus
so
sine
you
x,
can't, yeah, I mean, you can't just put it all over X. It has to be
just the sine,
kept
right?
this way.
Yeah,
So it ends up being dy dx equals sine X over X plus cosine X, natural log of X, times the Y. The Y was really X to the sine X. And so
yeah.
it always has this form, like it always is some derivative times the original function when you're all done.
Okay,
Okay, now in it to a lesser extent, there's a couple of problems here on your homework that you would actually use this technique for. And here's one of them. So you would want to do the natural log of y equals 2x, the natural log of cosecant 5x. There's no other way to do this, by the way.
okay,
There's not like, oh yeah, I'll try something else. This is it. So do you want to give this a try, please?
yes. Okay, I got two L. Oh, hold on. 2x.
Sorry, the main thing I would be concerned about is could you take the derivative of this natural log cosecant 5x?
Um, yeah, that's what I did.
Okay, and then you do get a cancellation, which you want to take advantage of.
Oh, okay.
So it ends up being 10x minus 10x cotangent 5x plus x natural log cosecant 5x all times y.
Which is cosecant 5x to the power
Yeah,
of 2. Okay.
yes.
Yep, that's what I
Um,
got.
Give me the derivative of the natural log of the natural log of x, please. That would be the
Okay.
next kind of thing you might see.
Okay. How do I find the derivative of 1 over x?
So right now it's 1 over natural log of x times the inside, the derivative of the inside function.
Yeah. Wait. I just figured out the inside function, so I ended up getting ln of. Oh wait. Yeah. I
So
did
one of the things,
ln.
yeah, that's why I brought this up because this could be a little bit weird, but it's like this. Y prime is 1 over u times u prime, and u
Uh-huh.
prime is 1 over x. So it's 1 over the natural log of x times 1 over x.
Okay. Oh, because it's of the inside. Okay.
Yes. Okay, let's try one more, I guess.
Okay.
Y equals x to the natural log of x, which relies on what we just did here.
Okay. Can you walk me through that one?
Sure, it's you take the natural log of both sides,
Okay.
and there's a couple ways to do this. You could treat this as like natural log of x squared, or you could do product rule. Either works.
Okay.
Um, but this is 1 over y times dy dx equals, if we do product rule, it's natural log x times 1 over x plus 1 over x times natural log of x. If we do it as power rule, it's 2 natural log of x times 1 over x, which you'll see is exactly the same as what you get here. Dy dx equals 2 natural log of x all over x times y, which is really x to the natural log of x, something like that.
Yeah, I got that.
Okay. All right. Sorry, that would rush through that one. Probably bad choice by me, but good job. So we can pick up